Yeah, welcome again. Happy to see all of you. Uh, Today we have the quite important topics to discuss, like OPA basics, revision, inheritance, and UML class diagrams. So these are the main topics of the software engineering, modern software engineering, and OPA basics. And I believe last time, in the previous quarter, we already touched a lot of them. But let's try to recap the main object-oriented practices, principles, basics, and I would like to ask a lot of questions to you. Please feel free to participate with your answers and also questions. And yeah, so that's the main topics we would like to discuss today. Quite complex, and the tasks and homework assignments will be also not so easy as you had before. Project 2 will cover UML diagrams. Project 3 will cover a lot of topics related to the polymorphism and inheritance. So please, yeah, pay attention and be attentive to all of the things. So let's proceed and let's start with the main definitions of object-oriented programming. So everything in our world could be described by objects. You're actually interacting with objects, with people, with transport, with your car, with your subway, with your food, with your university, and making interaction between these abstractions makes it easy to program them. Well, before that, you probably know that there was a paradigm of method programming, and everything were put into the single class splitted, not the class, single source of code splitted by multiple methods. It was quite hard to identify and debug the whole program flow. The modern programming actually relates to the classes and objects. Class, it's like classifications of object in the real world. Here you can find a good example of the classifications of animals. Yeah, we have groups of mammals, we have groups of other species, and they are classified. Actually, it's a class, and all of them could be identified by multiple features. Well, typical animal could be identified by name, for example, or by weight, or any other things. Objects, actually, it's an instance of the class. So precise animal is an object that you can interact with. So this animal can provide a voice, can, I would say its or their name, weight, and other things. Um, Another one good example is a car. So you can own the car, for example, Mazda with your own number, but it could be classified like a car and subclassified as Mazda car. And yeah, by interacting with your car, you're probably opening the door, you're turning on your engine, you're braking, you're switching gears in your transmission. So the way how you operate with your car, it's quite unified, right? So it could be enjoined in a class. So for example, turn on the engine, could be um, described in the same way for all kind of cars, Mazda, Audi, BMW, and other things. But for your precise car, it could have some kind of additional complexities or additional ways how to turn it on by key, for example, or by pressing the button. And that's something which provide the development much easier for you because it's obvious for the engineer what is going on with any kind of classes and object from the real life. So that paradigm started since the early 90s from the C++ language. C++ language was initiated by Bernd Stroustrup. A lot of principles described there, and it started to be quite common because programs started to be more understandable and much easier to debug and support in future. Right, so let's go to the more exact examples from your real life. So we have some kind of predefined classes in Java development kit, like example mass. For example, method mass random. It provides randomized numbers, and all of these activities joined in the separate class called mass. So we can expect in this class to have some helper method or some manipulation related to the mathematical operations. The same thing related to the date. As an example below, we can have the birthday and we can define it as a new object. Yeah, so birthday actually it's a precise the day when you have born, but the date is a class. So, and another one good example is a string. String used everywhere in your application. It's most common class in the JDK, and it provides a whole literal with a text or the name or other things. So in this way, we are classifying entities we are working with in our program, and we can understand what can we do with each of them. So for example, with math, we can operate mathematical operations. With date, we are operating with calendar dates. With string, we are operating with literals. Yeah, but guys, if you have any kind of questions, please don't hesitate to interrupt me. I will be happy to answer. Let's take a look on some of examples. You can define your own classes. Actually, it's a main task which developers are doing every day. So here, for example, on the left side, on the left top, you can see the circle. So how we can mathematically define the circle? It's actually the point with the coordinates like x and y. It also has a radius. So with both of these parameters, we can uniquely identify the circle. So what we can do with the circle? We can calculate perimeter, we can calculate the area, and that's actually, well, it could be extended, so we can transform, extend, or generate a new circle. But to keep the things as simple as possible, that's the way how we are defining it. It's a class. How we can initialize it? We are initializing it on the screen below in the main class. So as you can see here, circle C1 equals new circle. So we are defining a new objects. All of objects are defined through the constructor. Constructor is specified method, specified way to identify your object. So we can use default constructors, and Java has default constructors by default if you haven't overridden it. Also, you can provide your own constructors. With own constructors here, for example, you can provide details with a point, radius, and other things which you think make sense to have in your class to uniquely identify the object. Yeah, on the example below, you can see the way how to obtain the information and data from your class. So each of class has fields, methods, constructors. If you're talking about the Java fields, actually, it's a point center and double radius. Methods get perimeter, get area. Constructor described by default. So if you can see below, there's an example, system out println C1 center and C1 radius. So in this way, we are trying to get the fields from precisely this class we created. As we use a default constructor, all of these fields are not identified. So point is equal to null, radius as a primitive type equals to 0. So yeah, what does it mean? In case you will provide some kind of operations and try to get the perimeter or area for the circle, it will provide null pointer exception or provide even weird values. So it means in case you are defining the object, you need to take care about the validity of the fields and data inside your class. Yeah, and on the example provided on the top right corner, you can see the class with just default values. So in case you are not providing any kind of details in the constructor, all of these fields will be defined as default. So if it's a complex object class, like point, it will be null. Here, null is for point, for string. For primitive types, we have zeros as a double. For integer, it's 0. For char, it's also 0. Boolean b equals to false. There is a recommendation to keep everything clear in your program and define default values. For some reason, it couldn't be clear and understandable what was assigned here for the center, for the radius. That's why it's a good practice to provide the data from the constructor or by default in this field definition. We can take a look on it in the next slides. Yeah, as I thought before, we have default constructor. Every Java class has default constructor if no other constructor defined in a program. Again, constructor, it's a special way how we are identifying the object. But also, it's quite recommended to provide your own. For example, as we can see here, public employee. We are defining a name and salary. Of course, well, we probably have the same structure as with circle. We have a class employee. We have two fields, name and salary. So do not keep everything as null or zeros. We are explicitly saying what it should be, how it should be defined by default. Also, constructors may have a bunch of arguments. Again, if we are defining an employee, we can already say that the name should be assigned and salary should be defined as well. Yeah, you can see two parts of the code below. It's actually making the same thing, but with one main difference. If someone would like to explain what is the difference between these two examples, please raise your hand. Yaroslav, perfect. Yeah, please go on.
Do you hear me?
Yes, I can.
So actually, there's no difference between them, but the keyword this tells us that we are not working with local variables, string name and double salary, but working with object from this class. So
Sure.
with the fields of name and salary.
And you're absolutely right. Well, we have the fields of the class.
So,
yep. Yeah, Yaroslav, you'd like
I
to?
can explain more.
Perfect,
So
please
we
go on.
can, we can transfer this object as an argument to this public employee, and work with without keyword this, but this simplifies the way not to transfer the object throughout like an argument of the method. So yeah.
That's correct. Moreover, just compare these two examples. Example on the right, it's quite human readable in case you are using this constructor somewhere else in your program. Because, well, if you're trying to define the employee, it says, please provide an N and S. What is that? Nobody knows. N could be like number, anything else, so it's not clear. If you're providing self-definition, self-descriptive variable names, it's already clear that we should provide employee name and salary. And it's quite recommended to keep your program, keep your class definitions as much understandable as possible. Yeah, and you're absolutely right. So in case when we have the need to access the internal fields of the class, and we have the same arguments or even variables inside of your method with the same naming convention, we should provide a clarity to the compiler. Here, this means that we are accessing the field of the object directly and assigning to the field of this object name the name provided from the constructor. I think it's clear. Any questions? If no, thank you, Yaroslav. Let's go to the next one. Good. We have method parameters. Well, I think a lot of things are clear here. For example, we have this static method, triple value, for example, and we have a simple double primitive variable with a type of double x. Yeah, and does anyone wants to explain this example in detail? So what is happening here? We have a static method. It gets a double number x. Inside of x, of this triple value method, we are saying that x now equals 3 times more than x provided before. In the main program, we are saying that 10% variable is a type of double equals to 10. We are passing this information to the static method and then printing out. But in result, we still have 10. Metro, please explain.
I think it's because in our function we have like a copy.
Mhm.
So we copy in without pointers. We just copy percent to our function triple value. And that's all.
That's right. Thank you. And Yaroslav? Yaroslav, please.
Do we have get pointers in Java? I think no. Yeah.
Actually, every complex object in Java has a pointer. So it's not a C++.
Yeah,
sure.
in C++ we've got actually pointers, pointer some. But actually here is we can just return the value and get it. So
That's right. So that's more convenient way how to do that. But here, these examples actually display we are copying the primitive types. What does it mean? In case we have a double as a primitive, and we are passing through this double here inside of this method, compiler under the hood provides a copy of the primitive data here. So in case, if you're manipulating with this simple argument variable, it just works on a copy provided from the external program. So that's why you haven't changed it here in the main application. So we need to understand that primitive types in Java being copied. Complex objects like circles, as we had before, employees being provided by the pointer. So we are not copying the whole object. We are providing a link to the memory, to this object itself, which should be operated here in this method. So I believe, yeah, in next example, you can see that. So does anyone want to explain what is going on here? Yes, Yaroslav, please.
so we're creating new object of the circle, class circle, and then we are assuming the value of it as 5.
Perfect, yes.
Yeah, and then we call set new radius, and given the pointer to of the object circle as an argument. So we are creating a new linking variable of circle C in the set new radius, and assuming it assuming to the radius field, the 10. So actually we are, in every method we are creating a new stack, but in this stack we've got the link to the same object from the heap memory. So we are
Perfect.
actually don't change anything in the heap memory. We just copying copying the address of the heap memory.
Yeah, so I can, you're absolutely right. I can explain a bit simpler. And yeah, besides the previous example, here we are working with a complex object of the class circle. And we are not copying it. It does not make sense to copy the whole object. Object is a single and it was created here. So on the first step, Yaroslav, you're absolutely right. We are creating a circle object and it only once. So it's one circle. We are not copying to the second circle, to the third one. We have only one circle with set and provided radius 5 at the beginning. Now we are calling set new radius and we are providing circle objects to these arguments of this method. So what is going on under the hood? Here we are not creating a new object. It's absolutely the same object with the same address, and we are operating with the same circle. And now we are setting the radius to 10. Now, in the end, as we operated with the same object, now it has changed the context of the radius. Now it prints 10. And you need to remember that, so that primitive types are not are copied. So in case you are operating with them inside of the method, they will not have any kind of effect to the external program. These object situations are different. And Yaroslav also absolutely right. So there is a recommendation to do not modify the context of the provided objects in the arguments, but provide in return method a new one. Yeah, but nevertheless, this example is important for you and you need to remember that. Any questions here? If not, let's move on. Good. So it's a wrap up of the things we just discussed. So primitive types, when you pass a primitive type to the method, Java creates a copy of the original value and passes it to the method. So if we are making any changes to the value inside of the method, affect only the copy, not the original value. For objects, it's a difference. So we are providing the reference, the link to this object, pointer. So we are not copying it. We are just saying this address. Technically, it's the same object. And it's mean if we are changing the state, if we are changing any kind of fields of this object, it will be reflected in other parts of the application. Good. I think we cleared this one. Let's go to the next. Next topic is OOPA principles. Well, you can see here encapsulations, inheritance, polymorphism. And yeah, I would like you to participate. People in the classroom, please feel free to raise your hand, come closer to the microphone and try to explain what means each of this principle. And also people online, also please don't hesitate to raise your hand.
Can you hear me?
Yes, Eugenia, I can hear you.
Yep. So, sorry. Encapsulation is a principle that states that we have to not like hide, but like encapsulate everything in separate like objects or methods. So, for example, if we create a method and we write something in that method, it is doing something. Um, we have to provide like a clear name for that method so we understand what it does and we don't have to look inside the method every time we use it. So it is understandable on its own. So everything is like under the hood.
Okay, good.
Inheritance. This is a principle that every like class, it can have its own children class, its own parent class, and the children class, it can inherit certain properties from the parents class, like methods or maybe objects.
Perfect.
And
And
polymorphism. As far as I remember, this is a property of a class, which, like, for example, one parent class can have like different children's classes, and each of that children's classes can have their own implementation of the methods or objects used in the parents class. So one method can be used differently in different classes.
Good. Thank you, Henia. Yaroslav also raised your hand. Please, Yaroslav.
I've got an interesting fact, so to say. Every class in Java has his parent class. Its name
Good.
is object. So we've
That's
got
right.
all the basic methods from there.
That's right. So everything is an object. Object has a couple of default methods like wait, notify, notify all, and equals.
Yeah, to string, something like that.
String.
Copy.
It's more details, but you're right. So everything is an object. Everything inherits by under the hood. Every class actually in Java under the hood extends the object. Thank you, Yaroslav. Anyone else would like to say something? Well, generally, you're absolutely right. Usually for students, I'm providing a more simple and convenient example for encapsulation. Just imagine you are driving a car. It's manual transmission. So how you are interacting with your manual transmission? You are switching gears from the first to the second, and so on and so forth. For you as a driver, you just need to know how to switch between the transmission gears. In fact, how it works under the hood, it's not needed for you, and you shouldn't interact with some kind of details of your transmission. So, in fact, your transmission encapsulates the way how your gears are being switched from one to another. What you are doing, you're just changing the gears. And for all cars, transmissions may work in a different way. You shouldn't know that. You just need to know how to switch gears. And it's an example of encapsulation. So, for example, old manual transmissions have one principle how to switch gears, new one may perform it even automatically. But for you, it's an encapsulated logic. You're not taking care about that. That's something which transmission should take care about itself. The same for class. Class may encapsulate some kind of logic or even details of the implementation. If we had an example before, like for circle, we are getting the perimeter. Perimeter is actually the way how we are calculating the overall perimeter of the circle. And for you as a user, you shouldn't know exact formula. You just need to get the number. So this thing encapsulates the logic how to operate with the values and how to provide this calculation. Inheritance. Yeah, absolutely right. So we have the possibility to inherit one class to another. So probably it's mainly the terms from the biology, but it actually suits well even for programming. Well, we may have people could be employees, employee could be classified like external, internal. So you can see the classification process, and it could be splitted, and logic should be splitted behind the classes or animals. As I said before, we may have mammals, we may have some fishes, cockroaches, whatever. So they should be classified on a higher level, but each of them may have their own additional methods, additional values. And in this case, in case of inheritance, we are not duplicating the logic. All of general things generalized in a parent class. Just for example, when we are talking about the animals, each animal may have the name. So in general abstract class, we are defining an animal, its name, weight, and some other characteristics, and ways how they should be calculated. In case of inheritance in child classes, all of this logic being inherited. So it's implemented once and reused a couple of times in all of child classes. And polymorphism. Polymorphism also goes mainly from the biology, but yeah, for us, it's a term from the computer science. Yeah, so we can use a single interface of interacting with our classes, with our objects, but the details of the implementation could be different. Quick example, we have an animal. Animal can provide the voice. Dogs are barking, cats are saying meow, and so on and so forth. So we know that animal should provide the voice, but details are implemented in child classes. And in case, even if you are operating with the objects on a higher level, like animals, for example, and we are defining and working with abstraction like animal, but it's detailed like a cat, like a dog, system will already know that it should bark or say meow. Let's check this in details. Oh, sorry. Yeah, encapsulation. So does anyone want to explain what is here in this example? If not, I can quickly recap. So here we have example of a bank account. The class actually represents your account, and probably the main thing which interesting to us is balance. So balance variable is marked as private. It means it cannot be accessed directly from outside the bank account class. So we cannot change externally. It's not visible even if you create an object of the bank account class and try to set, write a dot balance and set some kind of values. It's prohibited because well, otherwise you can easily change the balance from other parts of your app. So it should be private, and we should operate with your bank account based on some kind of activities like withdrawal or even getting the balance. So that's something which being operated through the method. We have a constructor bank account initial balance. We are initializing your bank account. And method withdrawal says that actually we need to get the money, and it checks if the balance is not zero. If it's higher than zero, then we can get this amount and correct the overall balance of your bank account. Last method is a get balance. So it provides your leftovers on the bank account. So these methods are public. So it provides a controlled access to your bank account balance. And in this way, you can, the logic of your program guarantees that you can take more money from your bank account comparing to the available funds. So here you can see the example of encapsulation. We have the balance, which is encapsulated. We are not changing it from outside world, and we can just withdraw the money or get the balance. Like taking into example with cars transmissions, we are not manually switching gears inside of the transmission gearbox. We are just switching them by using the handle and manually switching between the gears using the manual handle. Yeah. So I think you understood this association. And this is the main example of the principle of encapsulation. Nothing should be changed inside of the entity, inside of the object. We are operating through the methods. In this case, we are guaranteeing consistency and validity of the information, and of course, security of the data inside your class. I think it's clear. Inheritance. We have saving account, extends bank account. Well, it's kind of a specific type of account. Might be credit, debit, but here we are describing the savings account. Of course, it has the same characteristics like a bank account. So it may have the balance, it may have the possibility to withdraw the money. But in case when we are talking about the saving accounts, we put our money based on some kind of interest rate. So this is the example how we are extending the logic of the base bank account. we are extending it. So the main difference from the typical bank account to saving accounts is just that need to store interest rate. We have constructor here, savings account being constructed and provided by the information about initial balance and interest rate. As initial balance logic already implemented in a bank account, we can call the constructor from the parent class. We have a special keyword super, and by calling super initial balance, we are calling actually constructor from the parent class. Here, this one. And of course, we need to initialize the interest rate. Interest rate being stored as again as a private field, and we are adding additional behavior. We are saving, we are getting the interest interest based on your bank account details. So the formula is simple. We are getting the balance. We are recalculating interest rate to the as a percentage, and getting additional information how much more money you've earned. So as you can see here, by implementing saving accounts and extending the bank account, you are first focusing on the details which is precisely related to this class. All of the logic of bank account is inherited, so you are already using it and interacting with it by using the methods. I think it's clear. And method overriding. It's one of the mechanisms tightly related to the polymorphism. So we can change the way how the logic works of the parent class by overriding it without changing the structure of the main parent method. So we decided that saving accounts should have some kind of changes, and the way how we are withdrawing money should be changed. We have the way to override it. So we are providing specific logic to the object of the saving account classes, and we are calling withdraw and saying amount. This one calculates and validates the possibility to withdraw in a bit different way, because we have some kind of transaction fees in case we are withdrawing money. But nevertheless, we can reuse the logic from the parent class. Here, we are validating in a different way, and we are calling super method. Super method actually points to the implementation of the withdraw method from the parent class. And again, here we are reusing the same logic by applying additional transaction fee. So again, I think it's clear. We have some kind of transaction fees for the saving accounts, which should be taken and charged additionally in case when we are withdrawing. And we are changing a bit the flow how the withdrawal method works, and also reusing the method of the superclass. Is it clear for you? I think yes. Let's move to the next one then. Yeah. And a good example of this polymorphism. As I said before, we have this classes like animal, dog, cat. So animals like making a sound, and we have a specific sounds for dog and cat. Dogs are barking, cats are meowing. So we have here a quite interesting thing related to the abstract classes. What is the abstract class? Actually, it's a class which may contain some of generalized method definition. So as you can see here, we have the method make sound without any kind of implementation. In this way, we are explicitly asking to implement this abstract method in extended classes like dog and cat. So we cannot directly instantiate the animal, but in case when we are defining the child classes, we should provide the definition of this action, like make sounds and for cat and dog. Let's check on the code on the right side how it works. Well, you can create an animal. Actually, you can do that but probably in some of cases it may cause an issue. But the good examples are here when we are creating animal my dog as a dog and animal my cat as a cat. So here it's a key principle you need to understand that you can define classes, classes of parent objects as a child one, because it's pretty clear how to operate with it. So of course, dog is an animal. It means that we can assign class animal my dog and create it as a new dog class object, as well as for a cat. So here in examples, when we making a sounds, we are calling my dog, my cat. Both of them are classes of animal, but implementation is strictly defined for related to the each child class. And even if this is an animal and it makes a sound, we can hear bark and meow. So what you need to understand, you can assign to the objects of parent class the definitions of the objects of a child class. And it's obvious. Each dog is an animal. Each cat is an animal as well. I think it's clear for you. Any questions here?
What if we just call a method from the abstract class? Will it like have an exception or error? Or...
It will have an error actually. So this is fun example provided like an abstraction, but if it doesn't have any kind of implementation, in Java, it will ask you to provide explicitly as an anonymous class definition to provide the implementation of the make sound. So this example is quite general, but yeah, if you are defining it in this way, the definition of the make sound should be provided.
Okay, thank you.
You're welcome. Any other questions? If not, okay, let's go to the UML, which is tightly connected to the OOP principles. UML is actually Unified Modeling Manager, modeling language. And to understand what we are going to implement, it's good to visualize. And UML actually provides the possibility to construct, visualize, and specify classes and even more complex structure for your understanding. So we have two types of diagrams, like structurals and behavioral. Structurals are like composite, deployment, profile, objects, and other things. What we are interested in is currently class diagrams, where we can define all of the things. And again, behavioral is like a dynamic aspect of your application. Sequence, communication, timing, state machine mechanism, and other things. So why we are covering that? Before implementing anything in a code, you need to understand it in your mind, or even better, to visualize. And the UML is a unified way how we can achieve that. So let's focus more on class diagrams. It describes the structure of the system by showing the system classes, attribute, method, and their relationship among the classes. As you can see here, sorry. As you can see here, we have parent class animal, and we have child classes, duck, fish, zebra. This diagram displays actually what animal has, how we are defining this class of objects. We are defining animals class by age, by gender, and we have the methods like is mammal and mate. All of these child classes have relationship to animal. Duck is an animal, fish is an animal, and zebra is an animal. And this relationship actually shows this connection between parent and a child class. And it says that duck is an animal. So it's an is relationship. So duck, well, can have some kind of big color string yellow. It's like a constant. It can swim, it can walk. Fish, again, has method like swim, can eat and size in fits, and zebra, well, is wild Boolean and can run. All of this plus and minuses means it's a private or public method. Yeah, let's go in deep into the class notation. First of all, we need to provide a class name. The name of the class appear in the first partition. Here you can see example of the contact string, like a name, address as a string, age, and gender. It's a private fields, and these fields are defined in this contact. And yeah, they are called in UML class attributes if they are shown in the second partition. Yeah, here we have the name also, and we have a type. It could be string, int, char, or other objects, or other classes, or primitive types. And we have class operations, methods. In this example, we can create contact like a constructor. We can create contact as a constructor by providing name and age as well. So operations shown in the third partition, and they actually the services which can class offer and provides to the external world. Return type of the method shown after the colon here. Again, as this are constructors or factories, we should provide precise class name here. And yeah, related to the class relationship. Inheritance, as we saw before with animals. We have superclass, we have subclasses. It's a relationship. Duck is an animal. Zebra is an animal. So they are adjoining in this way. A simple association, structure link between two peer class. So we have class 1, class 2. As here you can see an example. We have a teacher and student in a school system. A teacher teaches student, but both entities can exist independently of each other. So we have one teacher, we have multiple students. So they are kind of associated, but they are not under the same class structure. And dependency. So here on the third example, you can see class 1, class 2. And if the changes of the definition, one may cause changes to the other. So we have a web application and a database. If the database class interface changes some of the methods of current database, the web application class may need to be updated to accommodate these changes. So it's called dependency relationship. Our students and classes and teachers classes are dependent from the entities in a database or some other objects. So that's how we are associating them in a diagram. And this one you need to remember before working on your home assignment related to the UML. Additional topics: aggregation, part of relationship. Class 1, class 2. Class 2 is a part of a class 1. Yeah, so one of good example, we may have a car and we may have an owner. So class 2 might be the person, like an owner. Class 1 might be a car. Object of class 1 and class 2 have separate lifetimes. Yeah, so car could be sold or without an owner, and yeah, they're associated, but well, it's even possible that car could have different owners, even at the same time. Example provided here, we have a library and we have books. Library has books, but the books are not dependent on the library for their existence. If the library closes, the books still exist. I think it's clear. And we have a composition, contains a relationship. Like here, you can see an example on the right side. So object of class 2 live and die with class 1. Class 2 cannot stand by itself. Here you can see the example house and the room. In this relationship, a room is an internal part of a house. It does not exist independently of the house. Good. I think it's clear. Any questions?
No.
Perfect. Let's move to the next one, static fields and methods. Oh, Vladislav, it was covered previously by you, but if you want, I can continue from my side because I'm already present.
Yeah, I forgot about this. Please continue for a second. He's saying that you can continue.
Yeah, thank you. Good. So we have additional construction like a static field in a Java. What is a static means and static context? We have dynamics context and a static. So for example, when we are creating a cat class or a circle class with a fields inside of it, all of them are created in a time when the main class object created itself. So they cannot exist independently. So each time you are creating a new circle, then each time then you create all of the fields like center or radius. Static, instead of the dynamic fields, created only once, and they are living for the whole time when the Java application executes. Let's take a look here on a class employee. Class employee has private int ID, it's a dynamic context, and a private static int next ID is a static context itself. So every time you're calling employee next ID, it will be available, even if no objects of the class employee created. But if you're creating a new employee, just in that case, you can get this ID, and for each new object of the employee, you will have a unique identifier. So that's a main difference here. So, like you can find here, just imagine the situation when we need to create, we are creating a set of employees, and we need to guarantee the uniqueness of the ID generation. And ID should be generated out of the box. So here in this example, we have the method setID, and setID provides an identifier based on the static field and increment it. So in case when we are creating employee object, we are getting the static context next ID, reassigning to this one as a primitive and incrementing the static field. So it's actually equal to this example. So for example, you're creating an employee Harry, setting ID for this employee based on the next ID field from the static context. Each time you will be creating new employees, Harry, Maria, whoever else, these IDs will be unique for all of them. Each of these employees will have unique IDs and their assigned field, but the static context, which is responsible for the generation of this number, will be only defined once and will guarantee the uniqueness of these numbers. Yeah, so quite good examples here. P number from the mass class. I think it's pretty obvious it does not make sense to make it each time you're creating the object. So that's why it was created in a static context, and you can reuse it as many times as possible without creating the objects of the class mass. So you're just calling mass.pi. Or pretty common system out class, which are used for printing, for getting inputs from the console. Yeah, so it already defined the stream of the output, and it's a single. So you are working with a single context of the input-output streams in your app, and it identified only once. As it's a single for the whole JDK, there's no need to create many of these objects. Yeah, additional good examples of static method is just powering. So power x by a. It means that in case we are implementing the static methods, they are working in a static context with only static variables. So for example, here we have the method next ID, get next ID from the employee, and it returns only the static values. So static method could operate only with static variables, and we are calling them by writing class name and the method name, and typically are used for the common operations without the context. So put x in the power of a is a general operation out of the context of the circle objects or any other mathematical operations. And that's how it should be used. Yeah, so when we should use a static method. So we are using them in case when the method doesn't need to access the object state because all needed parameters are supplied as explicit parameters. Example, powering operation. So mass.pow, get the base number, get the power number, and that's it. So it's not related to any kind of context to any objects. And the second, yeah, when a method only needs to access the static fields of the class, get next ID. Any questions here? Perfect, no questions. Then factory methods. Yep, we already talked about the way how we are creating objects from the constructor. It's a quite common way. But there is an additional even pattern in a programming and an object-oriented design like a factory method. Just imagine situation that you have the quite complex way how you are creating your constructor, and it's based on the set of constants. Usually it makes sense to organize them in a better way and provide a factory method in a static context, which can create this object inside of it. For example, number format for the currency formatter. We can have the currency instance for the number format, and it's the way how we are formatting the output of the double variable. And it may have different contexts. As you can see here, it may have currency and percent formatter. Under the hood of these objects, of this static method implementation, you can find the creation of construction, providing some of static strings and patterns. But nevertheless, to do not overcomplicate and reuse this logic, we can define the static method and call it from the external world. It's quite common. So here, for example, we have a variable x equals 0.1. If you are using currency formatter, it could be pointed out like 10 cents, $10 cents. If you are using it like a percent formatter, it points like a 10%. So static method could be actively used as a factory method. So when we are creating instances of this objects, and in case when we are collecting a lot of tricky logic inside of it, how the object should be created. And the main method of the application widely known by you, it's also the static, it's an entry point. So it's created once, it operates with application class, and it's an entry point. So if you are asked, have you used a static method, you should always say yes, because it's it's a main entry point of my application. And yeah, any questions related to this one?